Ah, sorry. Little technical issues. Yeah, the room got damaged by some sort of error that may have been made by me. So anyway, and then I'm having a little trouble with the recovery, and so yeah, sorry. There's an awful lot to do for one person. All this stuff, managing all this bullshit. So yeah, my bad. There we go. So it looks like it's working. So it looks like we're back and such. All right. Well, we'll do a little bit of screen crap. Might as well try this one this time. And we'll see if we can. We play just a little bit of this secret nature discovery thing, because I'm sure, yeah, it's not gonna be. It's not gonna prove anything with any evidence he has.
And I'll never get any credit for this. All the proof in the world, and then some. That I've
Okay, he'll never get any credit for this. He's making a public video, and he'll never get any credit because he discovered the truth through what?
finally solved the riddle of how birds navigate. Now you're going to say, oh, we knew how birds navigated. They navigated via magnetism. That's half the story.
Okay, that's half the story. Yes, there's different stories for different birds, actually, because, yes, some of them just have, it's not even magnetism, it's the, it doesn't matter about the north-south thing, it just matters about the down thing. So they're just going based on the magnet moves down. Yeah, and that's the part that matters.
Descriptions are never explanations. Okay? How do they navigate?
And it always goes down in the direction of it always point down in the direction of north and south. So it's not really pointing north or south, it's the downness is always directionally more north or south.
Navigate via magnetism. Well, some pigeons, for example, have magnetite particles in their beak. Well, that seems like an explanation. Most birds don't actually have that in their beak. What all birds have in common, however, and human beings actually have it, and I experience this when I experiment over top of that ginormous $1,000, 30-pound monster.
Yes, yes, yes. We've all heard about the ginormous 30-pound monster magnet. Whatever. Let's try a different screen share. I wonder what happens if I hit it twice. It just goes away. Okay. That's good to know. So let's go with this so you can see his video better. I suppose I could make his video full screen or something, but I really don't want to do that. Theater mode. That should be good enough.
Magnet, your eyeballs actually feel because human beings have cryptochromes, that's what they're called, cryptochromes, in their eyes. Nothing to any level like birds have, however. Now, there have been all these absurd, asinine explanations like, well, we know birds navigate via magnetism.
Well, you wouldn't really need more than one magnet to do the thing, you see. So what the birds actually do is they collect a bunch of them, and they all connect together. So they do grow one little magnet, because you really don't need one in every single cell.
But how? There is no animal on this world that can actually see magnetism itself. What nobody else was able to conclude is that what does magnetism influence such that birds are able to use it for navigation? Because it is absolutely 100%.
Well, whatever. We know that magnets, other magnets, so any paramagnetic material will become magnetic in a magnetic field, and therefore tend to line up with the field. So that's not news.
Impossible for birds to see magnetism in and of itself. So how the hell were they navigating?
So this is one of these straw men again. Like, and nobody, I don't think anybody was thinking they could actually. Well, actually, they do have some kind of theory now, don't they? I think where it's causing a redshift or something, because it's in their eye, and so when they look in one direction, it's the atmosphere is a different color than in the other direction. So there is actually some speculation they can see the magnetism.
Oh my God, there's some elaborate. Mother Nature is not a crazy hooker on crack. Now, I made this discovery.
Well, I don't know what that means in the context of your theory. A hyperburloid seems kind of like something a hooker on crack. Somebody asked me like, well, how are you going to invent a universe? You're going to make like a simple domino thing that your universe will be made out of, and the things will bang out into each other, and there'll be a conservation principle, like no domino can just appear, and no domino can not be banged into, and no silly rules like fairies just fly around. Or, is your choice going to be, I'll make a hyperburloid? Yeah, I don't know. That sounds like a hooker on crack to me.
Well over a year ago. I knew this from my formula. I've actually got several formulas in my free book. I'm not selling anything. I've written 7 books, by the way. One of them is insanely popular, and I do mean insanely popular.
Yeah, so insanely popular. I guess when he says that, what does that mean exactly? He doesn't link to this free book, by the way, which is kind of funny. So apparently you're just supposed to figure it out somehow, or go type in his name somewhere and find a link to it. I at one time did go to the book and try to read it, but yes, it's worse than the videos. But I probably should read because I really do want the punchline here. I mean, does this guy believe in God or something? I mean, what's the punchline to all this hooky pooky? Anyway, continuing.
Magnetism. Here's actually a magnet. I knew that a magnet. This is also the reason why seeds grow radically different when the seeds are exposed to centrifugal north pole magnetism versus centrifugal south pole magnetism. Guess which pole is which? I'm trying to show you.
So again, he's saying that the polarization of the magnet is somehow going to now bend light, which not really.
I'll graph here in a second. Guess which pole is which? I can tell simply by the color. Now, the guy that actually invented the ferrocell, I have 2 of them here. Okay. This is the larger cell. I actually put a block on the front of it to block out the excess light.
Now, the image he's showing is, has colors in it, but he uses colored LEDs. So that's where the colors are coming from. They're colored LEDs. It's not white light that's creating those colors.
And Tim Vanderelli, who has many patents, he's a brilliant genius buddy of mine. This is the large, rather expensive ferrocell. Even he admits that no one else, when I called him up well over a year ago, said, listen, I discovered something completely. Have you seen this before? No, he'd not seen it before. It's even the guy who invented. Brilliant person.
Well, again, but the context is this ferrocell has to be analyzed as what exactly it's doing itself. And Ken thinks it's actually bending light, which is quite ignorant.
Invented the ferrocell. Had never seen it before. This AM phase shift, which I knew had to be there based on my formula of magnetism. I've actually got 4 formulas that actually follow. It's actually called electromagnetic retardation. In other words, it's a phase shift. The simplest way of
electromagnetic retardation. Well, so I think there's a lot of retardation going around in your philosophy, Ken.
Describing this, and I'll get to the secret of Mother Nature and how birds navigate here very, very quickly. The secret of Mother Nature is that around every magnet, and it doesn't matter how the magnet is shaped, there is a phase shift. What that means is that there is a phase differential, kind of like a pressure differential.
All right, so he's claiming that the force, whatever it is, regular conventional physics would say the virtual photons. So the virtual photons emanating from the north side of the magnet are substantially different than the ones emanating from the south side of the magnet. That's his theory.
It occurs at the exact same ratio if you're to take an egg and cut it in half. You know, an egg has a fat bottom and a little pointy top. If you're to take that egg and cut it right in the middle, you'd end up with the bottom section being a ratio of 1.618033, so on and so forth, with the top ratio being 1.
No. Well, depending on where you cut the egg, if you cut it at its center, its focus, of any ellipse, the two sides will be equal. So, yes, if you cut it down the center, which means the linear center, yeah, that's the ratio of an egg, but all ellipses will have a different ratio, Ken.
That means you have compression on one pole and rarefaction on another. In other words, you have a ratio of 1 to 5. The compressed side...
ratio of 1 to 5. So again, this is a conservation argument. So do you or don't you believe that you can't just invent extra stuff? So whatever's going down a drain somewhere, there has to be just as much being pushed into the bucket, so to speak. You can't drain more out of the bucket than you put in the bucket.
Always be towards the blue shift. That's actually, there's a detailed explanation for that in my book, which is completely free on archive.org, by the way. It's also called electromagnetic retardation. But
archive.org. So why don't you just post a link? Why should I have to go to archive.org? I mean, why does it have to be archived? I'm pretty sure you have an active website. Why do you have to archive it? Seems like some sort of gimmick there.
Electromagnetic retardation was never discovered vis-a-vis this. We've known about EMR, electromagnetic retardation.
I don't think we really have, so I don't know what the hell you're talking about, but fine, whatever, blah, 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 blah.
For a long time, but we had no idea until I discovered it, and I actually discovered it in my own formula. Then I actually found out the inventor of this ferrocell about a year later, and then I went looking for something that I knew must be there, and that's exactly where it was. This side you see is blue, this side you see is red. You can actually see another example of it here. You see the top.
Right, so it's just a very little tiny bit of red there, but the whole thing is this orange color because of whatever LEDs he's using. So again, does that mean anything? And, I can't really, I suppose I could zoom into this or something, but I don't know if it's worth the trouble. But all these bent lines are just an optical illusion of the ferrocell itself. So this isn't an accurate, the magnet actually, here's the North Pole, here's the South Pole. You can see that it's been distorted in terms of the shape of the poles of the magnet even. So these are all just distortions of the magnetic field based on the fact that there's compression in the glass because the fluid all goes to these dark spots, the particles in the fluid, and that makes essentially a lens inside the glass. And obviously, you know what lenses do to light.
Top side is blue shifted and the bottom side is red shifted. Well, just simply by looking at the coloration, we know that this is the South Pole and this is the North Pole. Okay, let's get to the secret. By the way, before I get to the secret, Mother Nature is really, really simple, by the way. I mean, how simple is Mother Nature?
As well, by the way, he's never proven any of this like the way an experimenter would. That is, like you would take a magnet and randomize its position in the field and then attempt to accurately detect it. So just like a psychic who should be obliged to do these card tricks and prove their ability, he hasn't even met that standard. So he's so passionate about this subject, and he's discovered something that no one else has understood or revealed, and yet he doesn't have enough passion to take the 2 hours to construct an experiment, maybe the 2 hours necessary to perform the experiment. I mean, I'm giving 2 hours. 2 hours to put tape on a magnet doesn't seem too, I'm giving him lots of time to fuck up. And then to have a system to randomize the magnet's position. So you just take the magnet and you put it in a device that randomizes it. And then you put it back in and you see if you can detect which side is correct. And then you test to see what side was the north and the south. And there's no evidence he's done any of this. So he hasn't proven anything.
Nature, really, really simple. Now, since we knew that birds navigated via magnetism, there are the most absurd, complicated explanations for how. There's even one that says there's like a quantum magnetics. Birds.
No, like most of them do based it on the fact that there's you can make a very, very small magnet. There's very tiny, almost atom size kind of idea, and so you can make a pretty functional magnet out of just a few atoms of this material. But that these are, it's very small, so you can have one that's inside of a cell that's as small as a mitochondrium or something, and so it's very small and it's a magnet. It's not detecting a shift. It's detecting the position of the magnet.
Are simple. I grew up with birds. I have a lot of bird pets. I'm very, very familiar with birds. A big bird lover. That is what we call
yeah, well, whatever. Tesla was one of those too, but at least pigeons in the city. Like he didn't have something better to do with his time. Yeah, right.
Convoluted explanation. Absolutely impossible. There's another one which seems kind of reasonable, but would never explain how a bird can navigate in bad weather as long as there's any light at all. Any. Even moonlight. Any light at all. And birds have big eyes, by the way. You know that, right? Even when it is pitch black outside, there is still some light creep.
Well, it really doesn't have anything to do with how big your eyes are when you come to low lux capacity. So the ability to form a signal out of low light really doesn't have much to do with how big your eye is. The more important thing is how sensitive your retina is. But whatever. So you got another thing wrong. No big deal.
Over the horizon. Not for human beings in total pitch darkness, but for birds, yes. So even when there's like no light at all, like a heavy storm, you see, here's one of the most accepted explanations, and it's well, if you go towards the north and south this way, like the Earth curves towards the South Pole here, and it doesn't talk about coloration. No. That is also an extremely convoluted explanation. By the way, the Earth's magnetism.
No, it's really not that convoluted. That the pattern would keep decreasing as you go down the horizon. Things would keep pointing down. That is factually factual. So, but whatever.
Not my premise. This is a hardcore fact that's been known for a very long time, of course. The Earth's magnetic North Pole is located in the south geographic pole, as you can see here. Okay, yeah, down in Antarctica is where the Earth's magnet.
Yeah, right, but that doesn't really, that's just verbal garbage, so no one pays any attention to that. It doesn't matter. I mean, it's not terribly relevant.
Magnetic pole is, and up at the North Pole is where the Earth's magnetic South Pole is. So to a bird, the geographic north looks blue, and towards the south, the actual physical south, not the magnetic south, because the magnetic south is in the north and the magnetic north is in the physical south. Towards the actual physical south of the Earth, to birds, the light looks red.
So another part of this might be that, look, the whole northern lights are created by, solar radiation hitting our magnetosphere. And if there was a difference, then there would be some argument that the lights in the North Pole are bluer and the light in the South Pole is redder. I haven't heard anything like that, Ken.
So when a bird's flying, this is how simple Mother Nature is. Vis-a-vis the enormous amount of cryptochromes that exist in a bird's eye, and given the fact of my formula, which was totally my discovery, which I actually have tattooed here on the side of my hand. Totally my discovery.
I don't know. What was this discovery again? I missed it.
Absolutely wonderful. See, when I've actually mentioned this to people before, it's like, well, we knew that birds navigated via magnetism. No. That's not even...
Yeah. And you haven't proven anything. Again, so he's saying that the birds can see the change in light. So light is bent by the magnetic field. So their photon-capable eyesight is not distorting the light. No, the light is already distorted in the field, and they're seeing the distortion. Or, he's saying, the light comes into their eye and is bent by magnets in their eyeball that somehow are still able to detect. I mean, see, when you get too small a magnet, it's not going to be able to move very much. And so it won't be very flexible. It won't be in a frictionless environment. And if it's not in a frictionless environment, it's not going to be able to orient itself on poles. So too small a bit of magnet isn't going to be any good either. So anyway, that doesn't make a whole lot of sense to me.
Even half the story. How do they navigate via magnetism? These convoluted explanations not only have absolutely no proof, for which I have right here. Oh, I've got.
Well, they actually do have proof in the sense they have photographs of the magnetic material in the cells in the bird's brain. Now, you know, that's kind of proofy.
Proof galore, baby. Not only do they not have any proof, but their explanations make Mother Nature seem like she's a crazy hooker on crack. Birds, I mean, these...
No, I think the explanation that they are able to construct, just like we can construct toenails and all kinds of different materials, that their biology encourages the creation of little tiny bar magnets inside of their cells that will move or orient itself towards the poles. But like I said, the argument is it doesn't really do that. It just points down, and it's just the down part they're using. But anyway, it doesn't really matter.
These theories of how birds navigate via or using magnetism, you know, are as convoluted as saying every bird's got like a magical calculator in their pocket and they use magnet. You know, no. It is literally...
Well, again, they have pictures of the magnets in the cell, so I don't think they're doing that. That's a straw man argument in the sense that it's a fake argument, in the sense that they do have images of it.
As simple as the cryptochromes in a bird's eye. When a bird is flying towards the north, the physical north, they see blue. If they start heading towards the south, they start seeing red.
Okay, so then why can't you do this by getting some cryptochromes together and making yourself a blue and a red filter out of cryptochromes? Why don't you show how you can use cryptochromes to filter photons?
A mix of the two, they know they're heading off to east or west. Okay? Very, very, very simple. You see this? Like if a bird was actually headed towards the...
It would matter which is on the right and which was on the left, obviously, because you couldn't tell west from east if you didn't pay attention to such things.
North Pole, the physical North Pole, which is where the Earth's magnetic South Pole is, you would see a blue shift at a rate of 5 to 1. This would be phi, and this would be 1.
So anyway, so all that 5 to 1 stuff means something to you people, right? So somehow it's this egg theory thingy, whatever that is, that all impresses you somehow. Doesn't do much for me, I have to say. So anyway, I don't know if this is worth the trouble. Let's just jump ahead to the punchline. Well, I don't think it's a punchline. I guess he'll just keep talking about how he invented it. But yeah, I wish he'd do more ferrocell videos, because there are just a pile of shit.
Towards the magnetic North Pole, which is located in the geographic south of the Earth. If the poor little birdie sees blue light, it knows it's heading towards the geographic north, which is where the magnetic South Pole is. Okay?
Okay, so blue is south. Magnetic south, which is the North Pole. So blue is North Pole. At least we got that part right. So the north side of a magnet is supposed to be the blue side, and the south side of a magnet is, no, the north-south side is the blue side, which is the, yeah, well, that's all I can go by. I don't know why he had to confuse things by talking about magnetic this and magnetic that. Why don't you just pretend that has nothing to do with it and just do the north-south thing?
How simple is that? You want to talk about simplicity being divinity and Occam's razor? Like the simplest explanations are usually the true ones.
Yeah, I don't know if anybody wants to do this divinity thing. So simple is divinity. Yeah. So is this a religion? I mean, what exactly are you talking? I mean, if you're just doing religion, I'll go away. Yeah, because I really don't have any interest in in debating theists. So I mean, if you have some sort of God theory, then just out yourself and point out how you're not doing physics, you're doing theology. And I'll be happy to resign from this conversation.
This is Occam Razor. This is Occam's Razor in highest clarity and fidelity.
All right, so we just laughed that this is Occam's razor, which means this is the simpler answer, is that light's being bent by magnetism, something that there's no evidence can be done, that light can ever affect magnets. I mean, that magnets can ever affect a photon, except when they're going through a medium, and you use a lot of magnetism. So, you know, again, whatever.
Little birdie flies along, and the cryptochromes in their eyeballs, they see blue light, they know they're headed towards the geographic north. They start turning, and they see red light. The more
So again, the cryptochromes are somehow a filter on the rods and cones of their retina. Where are these cryptochromes? Where are they doing this filtering, where they're recognizing blue field versus red field? Like I said, I'm all for having blue and red fields. I'm big on this whole color thing. But I do it just as a metaphor. I don't think, you know, there's actual color in magnetic fields. But anyway, it's polarization.
the intense the red light gets is at maximum intensity, they know they're heading due south. Everything else is navigating along.
Well, like I said, they wouldn't go by intensity because they really can't detect intensity. You can't, it's like detecting gravity over very small distances in a field. That would be impossible for you to tell an inch worth of gravity at, say, that distance from the sun where Saturn is. You won't be able to create any instrument to detect the gravitational difference over an inch. And the magnetic field of the Earth is so weak, there's no way that any material detector you could have in your brain or eyeball that it could detect differences over the small differences of travel distances. So there's no way that a bird could just, you know, wave its head and tell the differences that way. It has to be a physical magnet that takes a little bit of time to orient itself.
On like the seashore, how do birds navigate? I mean, once they can actually see north and south, everything else is just major landmarks. It's like there's the gigantic, of course, birds don't think like that, but I mean, they're thinking like, oh, super gigantic rock formation. Okay,
Yes, it's like a super gigantic fat ass, and you know, some men will go, "Oh, that's interesting," and so you have to have a program that, oh, that makes me think of trees, and then there's trees over there. It makes me want to piss, and there's a urinal over that way. So it makes the bird go the right way evolutionarily because the signal incites a feeling that's conducive to the right direction being a going.
but I'm the person that has actually told you, and I'm the person that discovered this, of how they navigate via magnetism. Thank you so much for watching.
So again, that was a how explanation. So you had lots of how in there, right? We exactly got the whole how thing. The cryptochromes did it, and they did it, you know, with the candlestick in, you know, whatever, Colonel Mustard's Mercedes-Benz. I mean, there's just no, you know, there's no how in any of this shit. There's no physics in any of this mush.
Great Mysteries has been solved by me. If you like this video, you could drop me a pizza or $2 or $5, or slap me in the face, or tell me to jump off a cliff. Thank you for watching videos.
Yeah. Whatever. Dos Bidonio. Yes. Let's just do some little language trideisms. Sayonara. Fuck you. Yeah, that's all I got to say. Anyway, so enough of that crap. That was terribly boring and uninteresting. Okay, so back to the real. So anyway, he has mentioned perturbations. Yes. I don't know what the hell they are, but there's 1 minute there's a medium and the medium waves, and the next minute there's no medium and there's just perturbation. So perturbation is just something that happens. It doesn't have any material magnitude. It's just a perturbation. So that to me is not really physics, but whatever. I mean, you can't really argue. You could just say, okay, a perturbation is a Tinkerbell. And as long as he argues that you can't make or kill Tinkerbell, so as long as he has to account for all the Tinkerbells, I'll say that's okay if you want to call them that. I don't care what you call a photon. You want to call it a perturbation, you want to call it a Tinkerbell, it's okay with me as long as you obey the rules that, yeah, photons can only do certain things. Photons can't lift, can't stop speeding trains with a single bound or whatever Superman could do. Lift tall buildings with a single bound or something, or whatever he could do. I guess he could lift trains and jump buildings or something. I mean, I guess it all has to do with making something sound good. But yeah, I mean, it seems like the Superman thingy should have said something like he can fly instead of this leaping and bounding stuff. He did. He flew. He didn't. He didn't really leap a building. He flew over it. But I guess it just sounds better to say, you can build tall buildings at a single bound. Stop speeding locomotives with a, I don't know what you could do to do that. But it doesn't really matter. So anyway, we'll get rid of this screen sharing thing. It's me again. So anyway, I am getting tired, disappointingly. I watched the presidential debate, and it just, it's just so, it's just so difficult for the brain to take it in, But yeah, Trump was just awful. So Hillary was quite competent and alive and did her job, and Trump was Trump, and he was just such an idiot. So what? I went bankrupt. So what? I was there. I did it. It's good business. Hey, they never proved we didn't rent to the black people. We never had to admit it. We just paid a preposterous fine to get out of jail. Yeah. So yeah, we settled. Yeah. Yeah. We paid a fine for not doing anything wrong. Yeah, sure you did. Disgusting. Anyway, but apparently he's not going to release his tax return, which is really disgusting that anybody would vote for somebody who won't release their tax returns. I mean, he's made all these statements about what a great businessman he is, what a great charitable, wonderful person he is. And if he hasn't paid any fucking income taxes because he's claiming he's broke, what the fuck, people of America? You can't get how that's fucked up. A guy who claims to be owned $10 billion hasn't paid any income taxes, and you're going to say that's okay with you? Come on. Smell that shit. Yeah, well, before the end of this farce that is the election, I will do something, but it is just amazing. Yeah, a loan from daddy. I mean, yeah, they're not even talking about the original money. I mean, it's just so funny. I mean, he borrowed money from daddy more than once. When he went the third time he went bankrupt, I think it was the third or whatever, the second time. I mean, if it wasn't for the daddy loan, he would have been really fucked. Yeah, there's no point in being terrified because the world's going to hell anyway. It doesn't matter who's running the boat. It's crashing into the iceberg. But just for the sake of realizing that people are idiots, you really don't want to think. You really don't want to say, oh, man, I'm living on a planet of scum. And that, we might as well have an Ayatollah Khomeini. We might as well just give the country to idiots because apparently this country's full of idiots. Greedy, selfish, stupid, fucktarded idiots. Anyway, really disappointing. And also, anything. There's always stuff that's, life is just difficult. But anyway, I was glad Ken responded, but obviously I'm very disappointed that the response was puke. I was hoping for something a little piss, maybe some poo, but puke. Oh, fuck, that's not gonna. What am I going to do with that? But I will endeavor to persevere, and that's all I can do. And I'll just keep pointing out how all these little minions and trolley followers with their little down ratings and the rest of their little gameplay are all cowards. They're all dickless fucking cowards. Shit talking, dickless. They are they are men of low integrity, and they probably got that way because their fathers were men of low integrity. I mean, how your mothers were fucking crack whores, okay, and your fathers were weaselly, thieving, scummy crooks. Because that's the only way you could be an asswipe who talks shit on the internet without putting anything up. If you don't have the balls to climb out from behind your little scurvy rocks and throw your insults in person when challenged, then yeah, you're a fucking coward. A cowardice little troll. Yeah, and your parents should be pissed on for raising trash. Ugh, I'm just so sick of the unaccountable. Yeah, so I do have the quantum model is in operation. I just haven't finished it. So I suppose I could show it to you if you do this screen share thing. Oh, it's on the other computer. And I can't screen share the other computer. So from here, so yeah, that won't work. I can screen share it from here, but yeah, you can't. I have the technology. But what I'll do is I'll put it on a web server so that in the future I can link to it. I'm still working on it, but it's got all the arrows. So just imagine a whole bunch of arrows on the screen, and I can make them red and blue and black and green, and then I'll have them all move around and shit. But yeah, I'm still working on the. See, I want to try to find a simple way to make the pressure thing that isn't round, because round doesn't do good geometry, if you know what I mean. But square doesn't really exactly work either for creating even pressure. And so it gets a little complicated. So I'm trying to find workarounds that make it easier to program. And you obviously don't want to have to move all the arrows every time, because then that just takes too much time. So you just want to move the ones that are relevant, necessary, absolutely necessary. So there's lots of algorithms, that I have to work on to expedite the process. But maybe tomorrow I'll have something worth showing. We'll see how my day goes. I do have to actually do some work on my real life, because it is degrading, and the winters are coming, and I ain't ready for it. And so I gotta quit fiddling around on the internet and get too busy on fiddling around on my life. But we'll see how it goes. So anyway, again, anybody who's willing to defend Ken's physics can think they can make a rational argument explaining what it is. Me and my audience would appreciate instruction and explanation if you can provide it. That's something coherent. Yes, it is getting cool. So I do have to wear some clothes sometimes. But I will attempt to keep it to a minimum. Yes, and the Amendum standards. Keep clothes wearing to a minimum. Yes, well, anyway. Yeah, I wasn't expecting much from Ken, but I didn't expect him just to be so evasive. I mean, there's all this bold talking, I mean, he's ridiculing, everybody, you know, insulting the intelligence of, um, you know, whole classes of people who obviously have intelligence. And that just seems like if you're going to play that game, you ought to be able to put up. You know, if you're going to talk that big a game, um, you shouldn't be running from the contest. So, well, he may just have a mental. I'm sure he. Well, he obviously has a "I ate many Napoleons" complexes. You know, he has lots of complexes about eating things. I think. I think he eats books. I don't think he actually read books. I mean, he says I have read more books on magnetism than anybody, but I think he actually ate the books. So yeah, that's it's not exactly the way you absorb knowledge. So we'll see if I can humiliate them. Cluck cluck, buck 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 buck. Bunch of chickens and chicken shitters, chicken shit eaters. Come on. Anyway, so I guess that's it for this. I mean, I just want to do a room because you know he did do a video, so it was some kind of reaction. But yes, it was useless turd crap. I mean, if it was like Revenge of the Nerds 3, did they ever make a Revenge of the Nerds 3? I don't know. They probably made a Revenge of the Nerds 7. But, you know, he's an insult to all nerds everywhere, right? I mean, I'm a test genius and I was a spectacular student and I was, but I'm a big, fat, nutless scaredy cat. I mean, is that Nerds Revenge 3? They all dress in their pink tutus and do their little spinning and la 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 off into the sunset. And that's what it looks like to me. So he's an insult to nerds everywhere. I mean, I'm sure I have some nerd genealogy, and maybe he's always had some sympathy for the, you know, narrow belted and high waistbanded and wedgied. I got wedgied a few times, right? Yeah. Yeah, give Ken a big wedgie. He's running home to Mammy. Probably where he gets all his love and money. Mommy. But anyway, what else is there to say? He does seem like the kind of kid that grew up way too rich, if you know what I mean. Often creates a nerd with a mommy complex. So anyway, yeah, that's enough. So yes, to get back to Aero Talk soon and see if we can arrange some sort of physics conversation for somebody who actually can talk about physics, which I don't think Ken can. He just can't manage it. Yeah. Anything physically physical. Yeah. Anything with magnitude in the physical dimension. Anyway, okay. Done my job. Shall move on to the next day where I will have to do my job once again. Anyway, good night to all, old fan and such. Thanks for popping in, being about. Michael, what's a Michael?
Hello.
What he's up to? Hello.
Hello, I can't see. Ah, hello.
There I am. Yes, there you are.
Nice to meet you.
Ah, so I see you. You silly English twat. No, sorry.
You said that you don't pick on people until
I know. That was a joke, right? That's a witticism.
That's okay.
Yes, that was a witticism.
I just like to say I really enjoy listening to you. I'm not a physicist. I'm sorry I can't ask you anything intelligent.
Oh,
but I just have to say, keep plugging away. I actually have written some science papers to people, and you are going to have a difficult time, but good on you. And don't worry about the haters. Just keep going for it.
Yeah, no, hey, you get used to this after 10 years, so it's not like they can actually dent me in any serious way. So
Yeah.
I just expected more from scientists. You know what I mean? You say that, like, okay, scientists would be up to debate, up to challenges, up to really want to demonstrate their truth. They have this vision in their head, and they'd say, "Yeah, I want people to be able to see what I see." And it just seems like you point out something obvious, like, well, here's a scientific experiment that's 100 years old, and not one scientist can accurately describe what took place, right? It's
Yeah.
only got two parts, right? Your light and two slits. And, not one scientist in 100 years can accurately describe even what takes place in the experiment. Not that they can interpret it, they can't even describe it accurately.
So you're talking about the
Yeah,
two split
yeah, I'm just
experiment.
saying it's just one example of these circumstances where you're saying you'd think scientists would want to recover from that and say, okay, I can explain why we can't do that. Okay, why
Yeah.
we can't get this right. And then you bring up something else like the fact that the Einstein lensing, the gravitational lensing thing that made Einstein famous, is an experiment never repeated, right? So science is supposed to be famous for repeatable experiments, and yet this proof that proved relativity has never been proven. You know what I'm saying?
Yeah.
The proof has never been substantiated by duplicating the results.
But those people aren't going to destroy that, because those physicists are deriving huge incomes from this employment, and it
Well,
is
I know.
like a
I'm just saying that I expect more. I expect that from, like, the lying preacher types. Okay, so they'll talk religion and they're just going to lie about religion. I don't expect it from scientists. That's all I'm saying. I'm just saying I don't expect scientists to behave like the Pope or something, or a politician.
But they do, and this is
I
quite
know.
obvious proof, right?
I'm just saying that that's the shocker, is that
It's like,
well, I guess I'm saying is that I can see how the talking heads do it, but I'm saying the day-to-day scientists who are defending them, those guys I think want to know the truth. They don't want to be part of a fraud or a fake. So I would think that they would have the integrity to say, I see what you're at here, okay? This is a lack of evidence, and they have to do better than this.
but they're not going to get this from you, right? Unfortunately, because they're not going to come and look at this video.
Well, I know, but the ones that have, the ones who have, the ones that I have encountered who have some scientific knowledge, clearly have no interest in defending the integrity of the science they're preaching. So they're going to keep defending a science that they won't, they'll just passively say, I'll accept that flaw. I'll accept this huge liability in the
But then
construction.
it brings about a whole other issue, right? It's like, then they need to accept that the world that they live in and derive their income from is completely wrong. And that's maybe a psychological hurdle that those people have to step over, that they can't get through. It's like if you try and convince a person that there is no God to become an atheist in one session, they can't do it. They just can't break through that. And you're dealing with that same problem.
Well, that's what I have concluded, is that, unfortunately, these belief systems aren't really about people trying to find the truth in some kind of honest way. It's just about people trying to defend their habits and traditions and lifestyle. And it really has nothing to do with what really has integrity or not. So it's just the fact that my people have been doing this for 200 years. So my people will continue to do this. And this is what my people do. And it doesn't matter whether it makes sense or not. And I just was kind of hoping that we're human beings a little smarter than that.
So have you written any papers off to any, I can't tell you exactly, but I have written some science papers to some institutes in America, and it's about the vortex of, I've written some science papers about vortexes and tornadoes, right? And because I think it's complete bullshit what they've told the general public about how these vortexes form. So I've written science papers, not that I'm a scientist, but just as a free thinking person like yourself, I've written letters to them with my thoughts on the matter. Have you done that? Have you written letters to people?
Yeah, well, I did the scientific publication thing. You have to go register and you have to file it in the PDF form and you have to do all this bullshit. But anyway, yeah, so I went through that process. But it's sort of like what I found when I became a temporary lawyer for a few years and was messing around the legal system. is that it's a fraud, right? There's no real standards, right? The law says like an appeals court has to provide an explanation, right? That's what you're paying for, is a justification for what happened. So they have to provide one, right? It doesn't have to be rational, but at least it has to be one. And you sort of expect the same thing from these publications is, and you're just saying, well, look, the guy who's reading this paper to decide whether it even gets to somebody who knows what it says doesn't know what it says. You know what I'm saying? The guy who's proofreading has no scientific competence. So how can he even judge the quality of the paper? You know what I mean? That he's going to decide whether it gets the time of somebody who's professionally qualified, right?
Yeah.
So, I mean, isn't that kind of a black hole of doom where you're never going to, it's like light escaping the black hole. You're just never going to escape the limitations of the editor. I mean, the first editor is the dumbest editor. And how can you get past the dumbest editor with a bold idea, right? Because he's going to be a status quo and is frigid and is frozen. He's going to be the hardest ice cube to break of all the ice in the institution, right? Because the smart guy, I can get to the smart guy because he knows what conservation means and he knows these certain rules. He knows what a virtual photon is and that sounds idiotic. So he would get the idea if I say, look, I got a way to make virtual photons real ones. And that guy would say, yeah, that makes sense. Where the imbecile is just saying, this guy doesn't think Einstein knows what he's talking about. So I'm never going to get past the first. This is a long way to say I can't get past the first filter. So, that's just not going to be viable until they have to do it. You know what I mean? Until there's some sort of I have 50,000 people saying, read this paper. So until that happens, I'm just not going to have the clout to force somebody to be accountable and say, why am I wrong?
And they're not going to want, and those people that you need to go right at the top of the pyramid, right? They're not going to acknowledge it because they're the people that are bullshitting.
Well, I know, but see, they're going to acknowledge it once it's a public statement. You know what I'm saying? They have to actually respond to it. So that's all I'm saying. When you're going for publication, the whole idea is that they actually have to point out why you're wrong if they accept it for scrutiny. All right. So once that takes place, I mean, once you're getting judged, it's like Einstein, they didn't publish Einstein once, right? Einstein was a little bit insulted, right? And but at least they gave an explanation. They couldn't not publish him without providing an explanation. So they at least explained why they didn't publish the paper, even though their explanation was kind of silly in the sense that they said, well, look, you invented quantum mechanics, but we sort of own it now. And frankly, you're fucked up. You don't get it, which was kind of funny.
So there you go. So Einstein eventually did get published, but what he wrote was lies.
Well, it's not that Einstein was a liar. Einstein was just wrong.
Well, yeah, okay. Well,
I mean, Einstein wasn't in the same class as the guys, these guys teaching physics. Einstein was really a specialist physicist, right? So in his specialty, he was really good in the sense that he knew the math of the effects of these forces. He didn't account for the forces. So he's essentially, I mean, bent space is almost like, for Einstein's time, it's almost the same thing as saying dark matter or virtual photon. You know what I mean? It was just a place from which to derive an effect, okay, where you could get outside the material dimension where you had to account for energy, right? By creating bent space, he had a new source of energy. See, there was no way to make energy to move planets, right? So
unfortunately for me, you're getting too technical into a subject that I don't understand. I would like to talk to you more about it, but I'll just have to sit and listen. I can't acknowledge some of your statements. I don't know enough about it.
Yeah, well, no, I'm just saying that if you can imagine that that it would require energy to move an Earth into a sun, is all I'm saying. You would surmise that you couldn't make something go someplace, especially something as heavy as the Earth that wants to go somewhere else, right? The Earth is going, whatever, 26,000 miles a second or something that way. And it's forced to go this way towards the sun, right? So I'm just saying you would understand that there has to be energy that makes that happen, right? It can't happen from nothing. So all I'm saying is that because physics had no way to derive a source, right? The Earth doesn't lose mass. the sun doesn't lose mass. So no energy is being consumed to create this union. So the sun and the earth move towards each other, yet no energy is consumed. You see what I'm saying? Like no batteries are required. So you know that you're not going to get light out of a flashlight with no batteries, right?
Correct. Yep.
Okay. So the point is you're not going to get movement of heavy material objects without using some batteries.
Yep.
If you get what I'm saying, right?
Yes.
So in physics, this was their dilemma with gravity, is they had no explanation for where the energy comes from. So by bending space, they essentially create a battery that's outside of real physics, right? It's a magic battery, right? You just pull this thing down magically by mass, right? Which is free. See, mass is free. So the mass pulls down the lever, right? And you get free energy. So that was the joke, right? Is that, you know, that's the battery, but it's outside of real physics.
Yep.
Okay.
So they're making stuff up, right?
Right. So that's all I'm saying is that if it was in the current environment, you would almost say it's parallel to these silly placeholder excuse kind of physics. Like I say, the dark matter thing where they just invent it to solve a mathematical problem. Well, quite obviously, bent space was just invented to explain Newton's gravitational law.
Fairy tale with some mathematics, so they make up rubbish.
Right. Well, they had no way. Like I said, it wasn't consistent with the laws of conservation of energy. So when Einstein says E equals mc squared, that can't be accurate. You know what I'm saying? In a universe where you can have magic sources of energy. You get it? If something didn't lose mass,
so hang on.
If the Earth or the Sun didn't lose mass, you couldn't explain where the energy comes from. You see what I'm saying? E couldn't equals mc squared. Mass couldn't equal energy if you could derive energy without reducing mass somewhere, or vice versa.
Yep. I just wish at this stage I was the particle physicist you need to speak to. I can't comment on some of the things you're saying because unfortunately for me, I don't know enough about it.
I think I'm just trying to make it mechanical enough that you can get it, that the idea that movement can't really happen without energy.
Yeah, but this is the problem, right? This is simple for you, but it's not for me because I haven't spent enough time on it. See, I could start crapping onto you about something else and you'd be like, what the hell is this guy talking about? Which is interesting, right? So when I wrote my science paper about the vortexes, I had that same problem you've got. The people that you're talking to don't know what you're talking about and they think, is this guy a lunatic? But you know in your mind, Gary, and I know in mine, that the subject matter that we do know about, we believe it is absolutely true and correct and that other people are wrong, right? So I am going to jump to something else. I was in a coffee shop not long ago and I happened to sit down next to a woman with a very English accent. She was Chinese, she was educated at Oxford, and she was a particle physicist. And I started to tell her not specifically about you. And I thought, man, it's the wrong person sitting here. I was thinking about how you need to be sitting there talking to her. And she was telling me about spin. And about 2 weeks ago, I started asking you questions about, on your channel here, I was asking you some questions about quantum physics. Have you watched videos? And silicon chips. Because that woman in the coffee shop was talking to me about spin and particles, and that's why I started to ask you some questions because I just wanted to keep your activity in the room live. Although I don't know a lot about it, I really want to encourage you. I know a lot of people attack you because they're small-minded. They're buffoons. Most of the people you're going to get here are only going to come to be entertained by your rants, which they are. They are entertaining, but that's not the purpose, right? You need to get to the right people that are going to listen to you, and unfortunately for me, I don't know how you can do that. I really wish I was the right person for you to talk to, but
yeah, well, I'm just saying, I think physics should be for everyone. So in a sense, I don't think it is that most of the concepts can be. I mean, look at the whole arrow thing, right? I mean, I'm breaking it down into something pretty simple, right? That you know, here you have a thing that moves the speed of light. Well, that's easy to understand. You have a thing that's always the same, so they're all the same cue ball. You know, so there's no distinction. And then you just have these simple, like 5 rules about how it interacts. You know, here it's a frisbee going this way or a frisbee going that way. So this is all understandable. So I'm just saying, I don't think I think physics can be understood. And I think most of physics, they make it more complicated than, I mean, it's like doctors playing
Absolutely.
Latin, you know.
It's like that. I think I mentioned lambda last week in a conversation, and I mean, I don't know a lot about lambda, but I looked at that lambda symbol, and it's like I went and Wikipedia'd lambda, and they even admitted there that lambda formula is a load of crap. They had to modify it, and they do. It's like bankers and banking. They throw up complex formulas so people don't understand fractional reserve banking and things like that. And the same with physics and doctors and all professions. They try to make money out of it, so they complicate it with complex language. And you're destroying that by showing arrows and making it simple. I actually reviewed your website the other day. I think you had a video from maybe a year or two ago. You were talking about how the arrows, they come in and they deflect off, but you've recently changed it, right? You believe they penetrate? Is that correct?
Well, in a sense, it doesn't really matter, because what they're really doing is just exchanging polarization. So in a sense, their orientation changes in the interaction. So it's just orientation. So you can almost think of it as you can think of it like a turtle shell, and there's no turtles in it, right? So if I just put shells in locations, and then I had a bunch of turtles flying around, right? And the turtle spent just a second inside the shell, right? And then he went a little bit and he hit another turtle with no shell, and that turtle took the shell. And then
so they're exchanging. They're exchanging shells, right?
So they're just exchanging the shell of polarization, you know. So the polarization's moving pretty slow, right? These shells are moving pretty slow. The turtles are going the speed of light, but the shells are just kind of moseying around, you know, getting moved here and there by how many turtles come from different directions.
Yeah, I did electronics and physics like 20 years ago, so I do, from some points, I can understand what you're talking about. I do know about electrons, protons, neutrons, all that sort of stuff, but it is funny when you talk about, see, even the turtle thing, right? I do have an understanding where you're going, but it's like it requires more thought time for me. Yeah, I mean, yeah, like it was fish. Actually, one of your explanations about the fish, you said it's the fish within the pool are moving at the speed of light, but the actual oh, that's not the right word. The entire mass of those fish are only moving like slowly, right? But within internally, it's the speed of light. And it led me to think I might be going the wrong way. Can you explain to me? So a human body is made up of millions of particles or protons that are moving at the speed of light, but here I'm just sitting. I'm just sitting here, right? So how does that affect our human body with all those particles? How come I can't understand these particles are penetrating me, right?
Right, but think of it in terms of the time difference, right? So from a speed of light perspective, our world is at this incredibly slow frame rate, right?
The things that we look
it's like there's a billion years of time happening in what really is 1 second for you. So 1 second for you is 1 billion years, so to speak, in terms of interactions. 1 billion interactions on the school scale, right? So, and think of it as everything's just going in straight lines theoretically. You know, everything penetrates. It's just that shell game. So you're just a bunch of turtle shells, all right, or your fish skin. And the fish go inside, sit inside of the fish skin, swim a little bit, and then take off. You know what I'm saying?
Not my reptile skin.
You know? So I don't know exactly how to, you know, I mean, whether I make it a suit of clothes or what I do, but the point is that the identity is what's changed. So all you're changing is the identity of a thing, okay? And that thing's identity is changed based on how much pressure, how much field energy is coming from any one direction, then it will own more suits. You know what I mean? So whatever energy is coming in is going to move the suits, okay, in that direction.
Yeah. I think.
So I don't know exactly how to say that, but I mean, you know, I was sort of wrong to imply. Like I said, I'm not going to. In the end, in the real physics, you know, the deep down stuff, it's geometry. You know, you really don't need you don't need orbits anymore. All you need is up and down. Because that's essentially what an orbit is up and down, up and down.
So you're saying that atoms with electrons flying around them, this orbital description of what's happening, you saying that's incorrect?
I'm saying, yeah, I don't think that's how it's happening. They're just moving, they're moving geometrically. So let's say, and that it explains a lot of things about the difference between electrons and protons, in the sense that if you think about them as being a piece of these turtle shells that are stuck together, right?
Yep.
Like 5 turtle shells stuck together.
Yep.
And so it's a little harder to move, right? Because it's more turtle shells, if you get what I'm saying.
Are we talking, hang on, so if I'm thinking about a magnet, it's more negative at one end and then positive and positive and positive, right? Is that what you're talking about with these turtle shells stacking up?
Well, I'm just talking about, like, say, inside of an electron. I'm just trying to get the impression that what it's doing is there's a piece inside of it, okay? And just think about, at any one point in the entire field, there's always arrows coming in, right? So no matter where I put my finger in the field, right, you can get the idea that the light comes into that one point like it was the center of the universe. Even though it's not, it's always going to look like the center of the universe in terms of the energy coming in. It's the opposite of a light bulb.
I know you, I can tell by talking to you that you know what you're talking about, and I think that you're onto something, but the language that you're using to describe it, it's, you know in your mind what you want to say, but it's too hard and you need to work this out, because for stupid people like me, we can't take it in, or I can't. So I do, to a degree, understand, but I just want to keep saying.
Well, I'm just saying, let's say I put you in a field of piranhas, okay? I threw you into a lake full of piranhas. There's going to be as many piranhas coming at your face as coming at the back of your head, and coming at your side, and coming from this side. So I'm just trying to get the idea that the field pressure is always radial and complete.
Yep.
Okay, and completely balanced in a sense, right? In the ideal world, it's a balanced field, right? In a clean place, it's equal amount of piranhas. So unless somebody cages the piranha that are coming from one direction, there's going to be an equal number from all the directions.
So this is just an analogy for field pressure around me, right?
Right. So I'm just saying the electron's in the same circumstance. Okay, it's in a field, okay, of balanced pressure. So let's say there was a bit inside of it that didn't like the arrows coming in, right? It always reflected.
And this is your
arrow coming in, right? So it hates piranhas. So let's say I'm a glass bowl now in piranhas, and the piranhas keep banging into the glass bowl. And I hate piranhas. So every time I see a piranha, I turn around, go the other way, right? When I go the other way, I'm going to hit a piranha again, right? And then I'm going to hit a piranha again. Then I'm going to hit a piranha. So let's say I change polarization each time I hit the piranha, right? So I go from red to blue to red to blue to red to blue to red to blue, you know, that kind of thing's happening. So my argument, instead of an orbit, what I'm arguing is these particles are doing that. Now, I would argue that the big things, right, I'm saying that an electron is like a school of 1,000,000 fish, okay? It's 1,000,000 quanta. And a proton, right? And so I'm saying when those things are in atoms, they're doing a lot less. There's a lot of activity inside of those things, but them are kind of frozen. So electrons move and protons move, but they move like this, okay? They don't do this thing.
They're not orbiting.
They do this thing. Yeah, they're magnetically connected to each other.
So they're vibrating.
Yeah, their tension is magnetic. So if you think about magnets where you could actually have a pure environment where nothing jostled them, you could sort of understand that you could actually make 2 magnets float. You know what I mean? You could take 3 south-facing magnets and then put a north-facing magnet right above it. And in a perfect world of no vibrations, you could probably find the balance point, and you could let it go and it would just sit there. But the reason why it doesn't work is the magnet flips over, right?
Yep.
So if it didn't do that flipping thing, you could float it. So I'm saying
I'm just trying to think of how this applies to electrons going down a wire, because I've been brainwashed into believing that electrons are in a shell and they get knocked out of their orbit and they fly down a wire, right?
Yeah,
so
no, see, they don't get knocked out of the shell. It's the free ones that are moving. That's the first thing. So it's at the end where the electrons leave, like a spark or something. It's where electrons are getting broken. Okay, that's where they're starting to lose pieces because they're being actually ripped out of their boundaries.
And they're converting, and they're becoming a photon, or
well, they're releasing the fish. The fish are the photon. right?
Yeah, I recall you talking about this a few weeks ago, and I asked a question about when I turn on a light bulb, how does the energy get released as a photon? And you said, it's the photons are already in there, they're just converting, right?
Right. So they're the fish. They're the fish in the school. So the electron's full of 1,000,000 photons, what could be photons, right? There could be gravitons, there could be magnetons. So the only difference between a magneton and a photon is the magneton has the polarization, but a photon has frequency. So the bullets come at a fixed time interval.
So they're all the same thing.
A photon is a sequence of fish coming at the same polarization from the same direction. That's a photon. And a magneton would just be a single fish with the polarization.
I'll have to review more of your stuff because I don't want to waste your time and talk to you. And
no, I don't mind. I mean, these explanations have to take place, so they seem like reasonable questions of, you know, you're being reasonably honest in just explaining that I haven't quite explained it sufficiently for you to understand what I'm saying, and that's important.
No, but part of that problem is that I haven't researched to talk your language, right? So, which is the problem that you and I have when we write to these physicists, and I've written to professors and asked them simple questions about clouds and they can't answer the questions. And even though you and I know that we will use simple language, I guess the point I'm trying to make is, one, the people that I have contacted, they don't know what they're talking about, but also I need to be able to understand the language that you're talking about so that I don't ask ridiculous questions and waste our time.
Right. Well, I'm just saying, if you thought of like electrons as being more cue ballish, okay, they're big things, not little things, in a sense. So all I'm saying is the quanta is much smaller than the electron. The fish are much smaller. So you could really think of electrons going down a wire, that what they're probably doing most of the time is just banging into each other. So one electron hits another electron, hits another electron, hits another electron. So that energy is going through them kinetically. So it almost gets like the steel balls that bounce. I could theoretically put 10 of them and swing 10 of them into 10 of them. And, you know, those 10 of pairs will be swinging back and forth. So electrons could transmit energy through a long string of electrons magnetically connected to each other. So it's like I could put a string of magnets, right? I could take 1,000 magnets in a string, and if I put them in a channel, I can hit one magnet at one end and make the last magnet move. And that movement will be much faster than the actual speed of electrons, if you get what I'm saying. If you actually had to make one electron make the trip, it would take longer than it would take for me to poke that and allow the field energy to move. Because the field energy is moving as fast as fish, right? So it's going almost the speed of light, right? The force in between the magnets moves at the speed of light, where the electrons themselves
I'm really sorry. I know what you're saying. I can tell when I talk to you that you know what you're telling me is correct.
Well, I'm just saying, you've seen magnets, haven't you? What's so complicated here? You've seen a fucking magnet repel another magnet, right? And you know, so I'm just saying. I'm just saying that this isn't that complicated. Let's see if I can find a bigger magnet.
It's not complicated, but my processing time to process what you're telling me is too slow to keep up with you mentally.
Well, I know, but I'm just giving you a pretty simple physical description of a circumstance. You know, magnets repel each other. So if I connect them all repelling each other in a string, right?
Hang on.
I have a line. I force them into a tiny little plastic channel. I put a bunch of magnets with the same polarization in the channel. You can understand that they would all repel each other, so there'd be a tension. Okay, so they're all under pressure. All right, so I maximize their pressure with each other. What I'm saying is, if I poke one of them, the thing that's going to do most of the moving is the space between them, right? That's the key ingredient, right? The actual magnets don't need to move very far, because most of the distance is going to be movement through the field of the magnetism. So what I'm simply arguing is that if I poke one here, it will actually move much faster than if I forced one magnet to move all the way to the end of the string and move. If you get what I'm saying. It would take an electron, a physical electron would take much longer to get there than the field energy of the particles in between the electrons. So when you think of an electron moving, what's really happening is a bunch of fish outside of the electron are going in a straight line, between the electrons, right? So those fish are moving in a straight line. Then the school of fish gets pushed. Then they go straight line. Then the school gets pushed. So the idea is they're going in a straight line much longer than they would if it was an electron. I'm not saying you have to understand all of that. I'm just saying the idea that you can understand that there would be a speed difference based on moving field energy versus moving a physical material object.
I can picture it in my mind. It's just that when you tell me these things, I'm trying to work out and validate the importance of that. So
well, it's sort of like the exhaust from a rocket is moving much faster going out of the rocket than the rocket moves, right?
Yeah.
Because the rocket, all that energy has to be spread over the entire rocket that's going, the matter that's going all the wrong way. So what I'm saying is if you did a calculation where you had space between the rocket, like space between rockets that move the same speed as the exhaust, I'm just saying you could sort of theoretically understand that while the movement was happening in the field, it would be much faster than when the rocket was actually moving.
Okay.
That's all. I mean, it's a long way to say that if you can string the things together, you can actually make movement in another place, not instantaneous, but you can make it go almost the speed of light.
I think for me, what I'll have to do is I'm going to have to go in a couple of minutes, but I'm going to review this video and I'm going to listen to what you've said again. So I know you're being very particular.
Well, I'm just explaining why. See, in certain circumstances, they might argue that electrons travel almost the speed of light. Like they'd say, like if I was to make a phone call to France through an electrical wire, the speed of the signal might be very close to the speed of light if I do it through a big enough conductor. And the truth is, though, that the actual electrons didn't move the speed of light. What happened was the electrons were all tied to each other, and there was a field push. The field push is what is being transmitted. So it's almost back to the two speakers with the string vibrating. You're vibrating the string. You're not actually moving string. You're just vibrating the string. If you get me.
I do. I'll have to have a bit more of a think about it.
Yeah. All right. Well, it's a good talk. Thanks for showing up.
Yep. I just wanted to sort of demonstrate to you that not all the people listening to you think you're mad, and we're not all pricks, and we're not all coming here to bully you. And it's unfortunate that a lot of the people are degenerate morons coming here to attack you. Even if you are wrong, they should be encouraging you to challenge the system anyway.
Well, I'm just saying anybody who's willing to defend an idea, somebody should give him a fair argument as long as he's going to give them, he's going to give them a fair argument back. So that's all. You know, I'm just saying if I start cheating, then you can rag on me. All right. If I start talking over somebody unnecessarily, or I block them unnecessarily, or I do something to cheat, well then, okay, hate on me. But until that happens, yeah, you got no right to label me the one unwilling to have the conversation. Because I'm here to have it.
It's really good to see. I mean, it's not something I'd want to do, get on here and be attacked by people, because basically you're trying to share what is pretty important information with people that just don't care about it. I care about it. I can't completely understand everything that you've told me, but I appreciate that you're trying, because I know from when I wrote some science papers, I found out a lot just by writing those science papers that the people you're writing to are full of shit.
Yeah, look, and I didn't get into this because it's going to make me money or because I had a hate against anybody. I got into this because it just sounded too fucking silly to me that photons can split in half, go through.
Actually, I want to ask you.
Do radar, do math, and then figure out where to land. Yeah, I don't think photons are smart. Photons have to be pretty damn dumb.
So I had a look at that. I had a brief look at that two-split experiment and the explanation where they're saying that the wave travels. Do you think somehow there was a breakdown where they knew that there was particles, and don't let me go off the wrong way here. Do you think they started off that, yep, the particles travel through the split, and it as an analogy, like you give fish and turtles, they started saying, oh, the particles become a wave, and then over time people just said, oh, it's a wave. So stupid people in the future could say, oh, it's the turtles without their shells. do you think just the discussion of particles to waves just got distorted and stupid people just learnt the wrong thing over time? Is that what's happened here?
It's hard to diagram it because, you know, like I said, Newton already knew about some of this stuff, right? So, I mean, Newton's rings are this famous thing. Like, they make an aperture smaller and smaller, right? I make a hole smaller and smaller. Where there's a point where what I'll cause, and especially in monochromatic light, is I'll cause the light to have rings. Okay, so there'll be a light ring, dark ring, light ring, dark ring, light ring, dark ring. So that's what will happen to monochromatic light with a small aperture. It'll completely cause essentially the same pattern, on, off, on, off, on, off, except it's circular, right? So circular, just cut the circle out and you get the same pattern, on, off, on, off, on, off, on, off. So all the way back in Newton's time, they knew this phenomenon existed, right? And like they forgot, and then they did this two slit thing, and they said, "Look at this amazing pattern. Where does this amazing pattern come from? There's two slits. How do you get this amazing pattern?" And then, you know, they did the water wave comparison, and so they just forgot about single slit. And then somebody brought single slit back on the table, and that's when they came up with the dark matter Huygens thing, you know, where, well, when there's a single slit, the wave really creates a bunch of little tiny waves in front of it, an infinite number of them, and they all interfere with each other and cancel out, and then you're left with two, the end ones left, and those two end ones make the interference pattern. And it's just like so funny because they just, all they did was turn the single slit into the double slit, right? So they just completely cheated, you know, manufactured a second photon to interfere with itself. When you logically don't have any reason to create a second photon, right? Logically, a single slit doesn't, when you see a single slit, it doesn't say to you logically, I have to find some way to get the photon to go through that other slit, because there is no other slit, right?
Yeah, I heard you the other day making an interesting mockery of that. You were saying how, oh, there's a split coming. I'm going to have to tell the other photon to...
Yeah, I got a Huygens, everybody Huygens.
I think on that note, Gary, it was very nice to speak with you. Hopefully in the future, I'll be able to tell my grandchildren that I spoke to an Einstein equivalent and he took the time to speak with me. I'm going to leave.
Hope it works out that way.
Thank you. I'm going to go and have some coffee and maybe bump into a particle physicist. But thanks for taking the time to talk to me. I might drop in on you again sometime. I did want to come back over the last few days, but I've had some work to do. So
yeah,
I'll let you go.
Appreciate it. So anytime you're around, pop the eye. Okay.
Righto. Thank you.
Yeah.
See you, mate.
Good.
Goodbye.
Yeah. Hey, there we go. Success. We've had success. A successful guest. Yeah, that's one. Yeah, see if that can happen again. But anyway, that was nice. All right, so let's see. He lives on benefits, question mark. Somebody's always being some kind of snark. Some Brits come in butts, others, well, I'm not going to do this Brit thing. I was just making a joke. I mean, it's fun to make fun of the British, but come on. Can you really say something about light dispersion? Can you say something about light dispersion? You know, it's about where the light's created. And obviously the light comes out of electrons, and the electrons aren't a single source. So the dispersion is created by the fact that single electrons don't produce that much light individually. So you have to have a bunch of them, and they're not exactly in the same place doing exactly the same thing. And that's why light spreads, is because the source isn't the same source. It's not a single point source, technically. It's a source spread over an area that produces the light, and it's likely going to be spread over an area that has a curve to it, just because the field energy is going to tend to curve most of the material forms if they had the choice. So it's like water bubble, you know, turns into a water drop. Why does it do that? Well, because it's the conservation of surface area. It's the smallest surface area that you're going to be able to create to fill the mass and to serve the mass. And that's because of the field energy. Take away the field energy, and all of a sudden water droplets go all over the place. Take away the gravity. So again, I don't know, why do I don't mean to be critical, but posting links like say the Wikipedia pages on Prism as if that's a question or a remark or a comment doesn't really say much, frankly. I mean, it's really annoying when people post links and like, okay, yeah, I don't want to waste my time. I gotta go to this page. Oh, it's a page on prisms. What are you implying? I don't know what a prism is. I mean, what use is that? I mean, what clearly doesn't seem to be understood by people is that you can't make white, white light isn't a single photon. Go make a single photon of white light. Let's see you do it. That obviously light is made out of um, the three colors, technically, some or none of the three colors. So the only place where you can get single photons, if you were to have such a concept as a single photon, like again, you have to have a photon, you have to have a recognizable frequency. So you have to have at least two on the same trajectory to call it a photon. But a photon, a thing you call a photon, could be more than 1 ton, depending on how long that ray of light is. Mind-eye blindness. That's an interesting thing. I don't know what exactly that is, but your brain can't see. Interesting. I will try to draw you a picture so then you have something to put in your mind that's blind, but whatever. Put in your pocket anyway. They show what as a wave. Looking forward to the business. I don't know. It shows how Prism works. Again, it doesn't show anything. You keep talking about it shows something. It doesn't show anything. It doesn't show anything about the mechanics. Why does the light get separated? Why does the photon of red and the photon of blue go in a different direction? They obviously hit electrons on the surface of the prism. It's entirely a surface phenomenon. So it's just like a lens. I mean, the light is bent going in and then the light is bent going out. And those two bends equal the strength of the lens. And they're bent because electrons are bent. When you bend the glass, you bend the structure of the glass. That means you're changing the density of the glass, which means you're going to change the position of the atoms, and changing the position of the atoms will change the position of the electrons by a little bit, and the position of the electrons is essentially where the gun is aimed. So the gun will shoot crooked, more likely, depending on certain atomic configurations. There's atoms that are comfortable and atoms that are uncomfortable. And uncomfortable atoms will produce electrons that come out crooked, photons, and comfortable atoms will transmit them straight. That kind of argument can be made. Well, again, I'm just going to argue a single photon as a concept has to be understood, that a photon is only recognizable because of its frequency. And I'm just saying, if I'm correct that they are particles, particles would, to have a frequency, the particles would have to have particle 1, particle 2, particle 3, particle 4. They would have to have, like bullets, individual entities. So you can understand, if the only way I could see bullets was that I had to receive the frequency information, I had to get the wavelength. The only way I can get the wavelength of bullets is I'd have to be hit by at least 2. So, but what they claim about single photons is, again, just kind of rubbish. Obviously, these are things they can't even, if they could see them, they wouldn't, they look how much trouble they have even aiming them. They can't even aim them well enough to do the 2-slit experiment with aim photons. And they're talking about that they know what a single photon is. And again, they're not single photons, they're single streams or single rays. They're single emissions of photonic energy. and those emissions go to the same location. But to call it a single photon is to, in my opinion, not appreciate that the tonness is really dependent on the source, and the source is producing these things separated by a distance. So it's a packet of two, and you could have a stream of a packet of two, I suppose, would be the argument. I mean, as small as the wavelengths of light are, it's still a huge distance in terms of the size of um, things like electrons and the distances in between nuclear pieces. So it's still it's not an insignificant distance. So Young's experiment is what? I mean, again, I'll just say Newton's ring. So every time somebody says Young's experiment, somebody else should just say Newton's rings. Young's experiments prove nothing. Absolutely nothing. And it was a hideously performed experiment. If you look at the actual Young experiment, it's a bunch of round, it was done in white light, it's a bunch of round balls, that have a bunch of blue shift and red shift. And, it's hardly a great detailed pattern. And obviously with lasers, the detailed pattern, the two-slit experiment produces two patterns. It produces the wavelength of the single slit experiment, and inside of that more on-off pattern. So it has two on-off patterns superimposed on each other. What's your wave experience explanation of that? That doesn't happen in water waves. Well, again, the deviation angle is the same angle that diffracts light in the single slit and double slit experiment. Light is being diffracted because it hits electrons. When light hits electrons, it can be diffracted. And obviously when the transmission capacity of glass, it's distorted when the surface of the glass, okay, is not balanced or consistent. So it's the change in the angle that the light is hitting the prism at will change at different frequencies of light, will be diffracted by a different amount, just as the light. The double slit experiment clearly demonstrates this. If you put blue light into the double slit experiment, you'll get a very different pattern than you get with red light. It's exactly the same diffraction. It changes how much deflection there is in the light. The light it changes the angle or the amount that it gets deflected, and that's changed based on how long the light travels in the electron that it hit. Light hits electrons, the electrons accelerate, they lose their acceleration because of the magnetic field they're trapped in, and they readmit the photon. That's how light travels. Light travels through, like so much light gets to your eyes that's actually had to hit stuff to get to you, but it hit stuff where it hit it was reflected, and the new light was transmitted at exactly the same angle that it came in at. And if that happens, then you have a transparent transmission. I'd say clearly the atmosphere is providing a fairly transparent transmission of light. Well, again, I've already answered this. I could argue to you why in the single slit experiment does a single photon, okay? Why does the pattern appear in the single slit experiment? Are you going to explain that? I've already explained, it has nothing to do with interference. It's an on-off pattern. On-off patterns can be created by a ton of stuff. It's the simplest pattern in the universe. I mean, shit, do I really have to draw another picture of this? But I mean, it's a deflection argument. If the electron goes this far versus the electron going this far in a field, okay, so there's a field. Now your photon comes in and it hits this electron. The electron moves. And then if the electron, and then it readmits the photon. So that's what happens in reality. This is Richard Feynman electrodynamics, okay? So I'm telling you, this is what your physicists believe. Richard Feynman would agree with this. This is a Feynman diagram. That a photon hits electrons. Electrons can accelerate. If they're in a field, they're going to be bound. They'll lose it. They'll lose their acceleration. They'll lose enough energy where they have to readmit the photon, so they do, and they release it at the correct angle. Now, if they're in a field, that means an electric or magnetic field. You know what they look like, right? Lines. If they're in one of those, then the electron might not travel straight, right? Because the field bends it. And so now, straight away from here, this arrow straight, no, this is straight from this the electron's point of view, because the electron didn't travel straight with the momentum. It was bent by the field. So now its momentum has changed. Now its point of reference, or its idea of straight, is here. So it's like its face was turned. So it's like me accelerating in a field, and the field turns my face. And so now if I throw up on you, I'll, I do it this way. It just changes the direction. So the electrons are what affect the photons. They're the thing injecting the deflection. They're making the photons change their direction. As Feynman states, photons go from point A to point B in a straight line. It's electrons that do funky shit. So anyway, so it doesn't matter how many photons you send, the stuff it's hitting is the field in between the slits. You're going closer to the surface. Closer to the surface means the electron bends more. Further from the surface, the electron goes straight. You can't understand that, for fuck's sake? There's no observer-dependent aspect. God, you're just so fucking stupid. Fuck you. It's the observer-dependent aspect of the experiment is more confusing for most people. The way it is explained to people. Like, again, there's no observer effect. That's just a canard. So yeah, that isn't part of the experiment. I mean, fuck, that's part of the craziest part of the experiment. That's part of the interpretation. That has nothing to do with whether there's an interference pattern or not. Observers don't make the pattern. Observers don't have anything to do with the fucking thing. I mean, observation would be, the idea of detecting a photon is ludicrous. Everybody should just admit that, and we'd be done with this nonsense. You can't rub up against a photon. You can't take a picture of one. You can't stick your hand out and just hit it a little bit. You either kill it or you don't kill it. But there's no fender bender with a photon. You just can't have a small interaction with a photon. You either completely interact or you don't interact at all. So there's no detection, there's no observer bullshit. Observation is irrelevant. What happens, happens. You can fuck up the experiment. You can catch it on fire. You can do a lot of things to fuck up the experiment. But fucking up the experiment doesn't mean that detection or observation had anything to do with it. So anyway, 2 hours seems like enough. I do have software to write and worlds to conquer and all of that crap. And it's actually raining. I don't know whether that's good or bad. Yeah, I don't know. I have to crawl into the house, and I can, I guess I have an excuse not to do it tomorrow because it'll be all muddy under there. So, but I can't keep making excuses to evade my work, and I keep doing it though. I say I can't keep making excuses, but I keep making excuses, which is pretty cool. No, you're just going to keep saying stuff that's going to piss me off. Let's make things simpler. The double slit experiment has two use cases, so-called observed and not observed. No, let's make it even simpler. I'm not even going to bother talking about observed. It's an idiotic idea. God, it's so fucking stupid. You can't figure out what slit it went through. It's an idiotic concept. The only way you can figure, you want to figure it out, the easiest way to figure it out is to aim the photons or to use aimed electrons. And then you can figure out what slit they go through. So as long as you aim them in the sense that you spread them over the entire surface of the slit, right? This is the experiment they really should do because they can do this with electrons. I'm damn sure they can. Fire the electrons evenly from every location on the slit. So just as many up here as down here, just as many close, just as many far. And I'll guarantee you'll get exactly the same pattern as the double slit experiment. So if you aim the photons and you shoot just as many photons here as you shoot here, as you shoot here, as you shoot down here, if you do that, I'll guarantee you the exact same pattern. Again, you're going to keep talking about detectors that can't work, right? So you're just ignoring the physical fact that we have never made a detector of a photon that doesn't change the direction of the photon. There's no such fucking thing. It doesn't exist in this universe and certainly not on this planet. So why do you keep talking about it, asshole? It's not an observer. You can't observe a photon. So you keep saying, I'm just going to block you. If you say observer one more time, I'm just going to block you. It's not a valid concept. You can't observe passively a photon. It's a fact. Look it up. I mean, you're just going to keep saying, Jesus says, Jesus says. You're not clarifying anything. You're going to keep pretending I don't know what observation is. I know what you can't do. You can't see the photon without destroying the fucking experiment. You can't do it in a magnetic field, you idiot. You can't see a photon with anything ever without changing its direction or its location. It's impossible, fuckhead. Well, that's not your point. Why are you bringing it up then? It's not an important part of the experiment. The interference pattern is the thing we're talking about, shithead. We're not talking about what slit it went through, you stupid fuck. Oh, you're just hopelessly stupid. There's no wave-particle duality. Again, you keep saying it as if it's true. It's not true. You can't detect which slit it went through. That doesn't mean they don't still think the photon went through both slits. That's what they think it did. There's no duality. They're just contriving extra photons to make them behave like waves. There is no second photon. There's no fucking wave. A photon isn't a wave. Well, you obviously don't care for the idea that electrons interact with photons. You don't seem to understand that. Do you understand that the only thing important about the two-slit experiment is the fact that there's four surfaces in the way of the photon? Can you understand that? And where do they talk about the surfaces? In any of the conversation about the two-slit experiment, where do any of these stupid motherfucking cunt physicists talk about the surfaces? The surfaces are clearly the thing causing the effect. Newton knew that with the small aperture. He deduced that, oh, it must have something to do with the fact that the volume of surface to volume of empty space is getting smaller. And that's why there's more diffraction the smaller you make the fucking hole. That's right, more surface, less empty space, more diffraction. Gee, maybe there's electrons next to the surface. Look, I'm not gonna, dumb nigger loving gook. I mean, that's a real brilliant argument. Slide 54. Yeah, I threaten to block people who are going to keep dragging the conversation into elements of physics that mean nothing. The observed photon effect is for kindergarten kids. It has even real physicists know that's not a viable conversation. You can't observe a photon. So fuck you. Well, I don't accept Huygens. Huygens is their formula. That's the only way they make the single slit diffraction work is Huygens. So certainly I don't accept that formula. I don't accept there's an infinite number of micro mini waves inside of a slit. The slit is a finite space. There isn't any infinite anything in there. So I certainly don't agree with the fake math of the single slit experiment. It doesn't matter. You keep saying stupid things like observation is considered an interaction. What I'm pointing out to you that you can't, if you're going to interact with the photon, you're not accurately defining why it went somewhere. So if I put a bunch of sticks in the way of the two slits, obviously it would be stupid to do the experiment because what's the point of doing it? I don't know what stick the light hit off of. I don't know anything. So it creates too much noise. You can't observe photons and then say, my observation was irrelevant. That can't happen. So you can't observe and do the experiment. It can do nothing but corrupt the experiment. I mean, fuck. You just keep reciting the stupid nonsense they keep saying. There is no wave function. It doesn't get collapsed. So you want to keep saying it, go ahead and keep saying it. It's nonsense. By that theory, a mirror, which is interaction, do you understand that a mirror must be interaction? Then a mirror must destroy the wave function. A glass lens would destroy the wave function. Well, how come they're still able to do the two-slit experiment when they use mirrors and glass lenses? Clearly, it has nothing to do with collapsing anything. There's interactions that are passive. There's interactions that are not. In the sense that you can put something transparent in the way, and that won't collapse the field. But if you put something not transparent and that it diffracts light, that won't work. And where we know diffracts light, well, we know a small aperture diffracts light. We know that for fucking sure. So obviously you can't put it through slits because they're going to diffract the light. Duh. Well, I'm going to copy this conversation with you, Daniel, pain in the ass. just for the record, just so people know that this was just a waste of time, that you just are incessantly just going to keep spouting the, Bible babble, pretending that this has something to do with collapsing wave functions and all this other bullshit, when I'm clearly arguing that none of that has anything to do with this. It's just a pile of shit made up by people who believe photons can figure out how to split in half, how to turn into waves, and then how to collapse back into particles. It's all crap. Photons are the dumbest thing in the universe, not the smartest thing in the universe. And I'm giving you a physical explanation that's fucking nice and simple and obvious and rational. And I'm explaining it in the context of Newton's understanding of small aperture diffraction. And but you don't want to hear it. Okay, you don't want to hear it. Anyway, had my fill, I think. So till the next time, and such and so forth and whatnot.